Hi, everybody. I'm Mr. Auerbach, and I'm here to talk to you about the Bohr model of the atom, named after Niels Bohr, the physicist. Oh, anyway, we'll draw on that in a little bit. But I am here to talk to you about this setup that you see here because we're going to start with it because that's probably where you started with the atom in, say, middle school or biology class or something like that. And it has a lot of things that are correct about it, like these energy levels. There are different distances from the nucleus that electrons can exist. And the each level out has more energy. And also the pattern that you probably learned in middle school or biology class or maybe your earth science class was that the first level of electrons holds two. E negative is what we write for electrons. So here they are, 1, 2. And then the second level though doesn't hold 2, it holds 8. And so I'm just going to do little chit marks here. Chit, CHIT marks. Don't start with me, people. 4, 5, 6, 7, 8. So there's our 8 electrons that are in the second level. And there really are 8 electrons in the second level. And then the next level has 18, and it sure does. I don't know if I can do this properly. I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, let's redo that one. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 electrons. And all of that is sort of true, except what the mathematicians and physicists figured out in the early 20th century is that it just isn't this simple. They don't really go around and around and around and around in a ring. Oh, that was terrible. But what they do instead is they sort of have multiple paths, and each one takes slightly more energy. And the way that it works is more like a set of Russian nesting dolls, in that you have orbitals inside of orbitals inside of orbitals. And sometimes, in order to make it all work, they aren't just rings, but there's other shapes inside of those. Let me show you what I'm talking about. I'm going to go back to my paint program here, and I'm going to delete everything. And I'm going to start with a circle here. And I'll draw. So the first level does indeed still hold just 2 electrons, and this is called, oopsie, this is called our, well, this is level 1, and whoopsie, this is level 1, and the shape of the orbital is an S-shaped orbital, which is a sphere. And so the electron will follow a spherical orbital. And then so this is called these are called your 1s electrons. And when you fill in 2 of them, you write a little 2 up here saying that you have 1s2. But then after that, you run out of room, and it's time to start another level. And this seems a lot like the last time, doesn't it? We're going to have another level here. Oh my goodness, let me fix that a little bit. Okay, we're going to have another level, and we're going to put more electrons. And actually, the first thing that happens is that there's another uh, s orbital that's bigger, and so let me redo that, make it bigger. So nice circle, right? So so this would be 1s, and this would be 2s. And if I just let me get rid of this for 1 second and show you what I'm talking about. Like here's sorry, wrong window. And again, wrong window. Here we go. So here's the 1s and the 2s, and you can see that there's sort of a neater geometric drawing here. There's the 1s, and there's the 2s. Here we see the 1s and the 2s, and then the larger 3s, which comes later, but we're not ready for that yet. And then you see what are called probability clouds, just like the electrons are most likely to be found in the darkest places, less and less likely as you get to the more diffuse areas. But anyway, inset within each other. Back to my drawing. We will then fill in our 2s2, because each of these little things is called an orbital, and or an orbital can hold two. So this is actually there's a better word to use for this. The whole level 2 is an orbital, but 2s is what we call a suborbital, as is, come on now, as is 1s, also a suborbital. Okay, so that's part of it. But when we get filled on 2s, um, what do we? Whoops, let me get my pencil going here. Oh no, I'm gonna get. Oh. So, question is, what happens after 2s? Do we then move to our larger 3s? But wait a minute, what about the other six? I thought that this held 8, and it does, but it isn't 8 like you might have thought. In order to understand that, I'm going to erase this uh, inner line here as best I can, and I'm going to show you that instead of all the Russian nesting dolls being round circles inside of each other, we have something a little bit different, and it's called uh, a p orbital. We would call this 2p suborbital because it's set within, and it's a different shape. It's a Let me see if I can draw this here. It's like a figure eight, and it goes a little bit outside of the s orbital. And so here's one, and these two aren't part of it. Let me draw in the electrons. And the thing is that the electron goes here, and what it does is it follows this path within, because that is sort of a way of fitting more in this area without them really running into each other or overlapping. Uh-oh, my light just went off. Excuse me. Thank you, I'm back. And so we have these, and the p orbitals they hold six, and they hold them two at a time. That one I just drew, and then that's on the whoops the the y-axis. Let's draw a line, right? Y-axis, and then I'll draw the x-axis. The z-axis is a little more difficult. I have to show you that in a second, but let me go back to this. So this one on the x-axis, it is aligned like, oh gosh, it's aligned like this, like a figure eight going this way. And so an electron that's on this one, I'm going to make it yellow just to give a little contrast. So the path is like this. And so they can all exist within this 2s or 2 level 2 space. And I'll draw the electrons. Here they are. And so these two electrons are only going here. So you put there's 2 in the 2p, and then you have the 2p, the third 2p orbital, which is very hard to represent. I'm doing it with dotted lines, and what I'm trying to show you is the z-axis coming out of the board straight at you in a z-axis line, in which, of course, you have to kind of use your imagination for. And let's see, oh, this doesn't let me do a dashed line. That's very sad. Okay, so normally I would do um, a dashed line, but we won't. We'll just go from here, and we'll just sort of pretend that this is coming out of the board. Whoops, it's a line. I meant to do the pencil. So we'll pretend this is coming out of the board here. And so an electron that was, so this holds two more. Sorry about my terrible drawing. But you have these two. So this can hold a total of six more. And so we would write, once we filled this in with its electrons, then we would write, the red color, 2p6. And so between the s orbital here, that the first two, that two electrons go on, and then the three different p orbitals, that's another six, two in the S and six in the P. And so then it's full. And I'm almost done, but I'm gonna go to one more level to try to introduce what's going to be happening next. The next level, you may remember, I'm gonna put a nice white square over. Well, we would get to our 3s, right? We would put 3s here. Let me draw in a nice big circle. That would be our level 3. I'm going to put a big filled white circle there. Okay, so that lets us look at just this 3s level.